Hello students, in today's session we'll talk about the application of binomial distribution. First of all, we'll discuss the assumptions regarding application of binomial distribution. The very first assumption is we should have n identical trials are to be performed. If we consider an experiment like rolling of a die experiment or tossing of a coin experiment, in tossing of a coin experiment, we need to decide about the number of times that we would like to toss the coin. Similarly, in case of rolling of a die experiment, we need to decide how many times we need to roll a dice. So is always a fixed number of trials for which the experiment is to be performed. Second condition is the outcomes are dichotomous. There should be two outcomes only when we perform this experiment. Either if we take the tossing of a coin example, then either head may occur or tail may occur. Similarly, if we consider the rolling of a dice experiment, so rolling of a die experiment has six equally likely outcomes if the die is fair. So how can we in fact generate or transform a binomial distribution? So we can decide about a specific number and convert it to a binomial distribution. Let's suppose if we fixed a trial, an outcome, which is if one occurs, then this is a success. If one does not occur, then this may be a failure. So the success has a probability of 1 by 6, whereas the failure has a probability 5 by 6. Similarly, if we would like to redefine, it will equal likelihood outcomes or equally likely outcomes. So we can define if even number of occurs, then we call it a success. If odd number occurs, we call it a failure. So out of 6 equally likely outcomes, there are 3 outcomes which are even and 3 outcomes which are odd. So the probability of getting an even number is half and the odd number is also half. So it looks similar to the tossing of a coin experiment in terms of the equal likelihood of both the outcomes. One we call success, another we call failure. There is always a fixed probability that we know in advance. So I have given you two examples already. Rolling of die experiment, either 1 by 6 or 5 by 6, may be the probabilities of success or failure if we fix a particular number or a face of die. Similarly, if we define our success as the occurrence of an even number, then 1 by 2 is or half is the probability of success and half is the probability of failure accordingly. So this is how we can do it. Now is the third assumption is the trials are independent. Now consider the example of rolling of a dice experiment. If we roll a die for 10th time, the occurrence of outcome does not depend upon any preceding trial or any preceding outcome. So it is not necessary if uh, we are tossing a coin for the 10th time. If in the ninth attempt we have got the outcome of let's suppose 1, so we cannot predict whether we may not be getting 1 in the next trial or not. So this is how, in that sense, the trials are independent. The assumption number 4 is the success probability P remains constant in all trials. Now let's take an example of the rolling of a die experiment. If all outcomes are equally likely, so whatever the number of times we are performing this experiment, So in each trial, the probability of success that we define remains constant. Let's take an example of even and odd outcomes. So if we are uh, performing this trial for the 10th time, the probability of success, if our success is defined as the occurrence of an even number, remains constant half, and the probability of failure also remains constant as half. If we perform this experiment for 11th time, 12th time, 13th time, or so on, the probability remains constant in all trials. So this is how we can understand the assumption or implications of assumptions are whenever we are conducting or applying these rules to identify an application as the case of binomial distribution. As far as formula is concerned, we have discussed the uh, conversion of the process in this formula, in this form already in the class. So this is probability of x can be obtained or estimated as ncx p raised to the power x 1 minus p raised to the power n minus x. Here n is the number of times that you are repeating or observing anything, repeating any experiment or observing any phenomena. X are the number of successes that you may achieve in n number of trials. P represents the probability of success, and 1 minus P represents the probability of failure. Now we are going to apply and use a sample data, or an example. Let's suppose a pharmaceutical company is willing to perform a trial on 4 patients, and there is a probability of success that they have estimated that the patient may be cured, has a chance of zero point 0.8, and for the failure 1 minus p, this will become 0.2 ultimately. Now we construct a table in which our random variable x will represent the number of successes that we may achieve when this medicine is tested on 4 patients. So there may be a zero success. Zero success means none of the four will be cured. Then one success. Either of the four individuals on which the medicine is tested is cured. There are two individuals out of four that are cured, three individuals, or four individuals. Now if we apply the formula to estimate the probabilities, the formula is P of x and Cx p to the power x and 1 minus p to the power n minus x. Now 4c0, p has a value 0.8, so this has to be raised to the power 0 because no success is achieved. Then 0.2 to the power 4 minus 0. Then we have 4c1, 0.8 to the power 1 and 0.2 to the power 4 minus 1. Then we have 4c2, 0.8 to the power 2 and 0.2 raised to the power 4 minus 2. Then next is 4c3, 0.8 to the power 3, 0.2 to the power 4 minus 3, then 4C4, 0.8 to the power 4, 0.2 to the power 4 minus 4. Now, using your calculator, you can easily work out the probabilities. 4C0 is 1, 0.8 to the power 0 is also 1. So that's 0.2 to the power 4 is the only factor for which the value has to be worked out. That's 0.0016. Then we have zero point 0.8 multiplied by zero point 0.2 to the power 3, and 4C1 is 4. So that's 0.0256. Now 4C2 is 6. So 6 times zero point 0.2 to the power 2 and zero point 0.8 to the power 2 and zero point 0.2 to the power 2. So that's 0.1536. And then next is 4C3 is 4. So 4 times zero point 0.8 raised to the power 3 multiplied by zero point 0.2 raised to power 1. That's 0.4096. Then we have 4C4 is 1. 0.8 to the power 4 is the only factor that needs to be worked out here in this case, because 0.2 to the power 4 minus 4 will give us 1. So again, when we multiply out, when we work out the probability, this is 0.4096. When we add them all, the sum of probability will be, all probabilities will be 1. So 0.4096, let's have a check for this. Plus 0.1536 plus 0.0256 and plus 0.0016. So that's 1. Now if we would like to work out the mean and the variance, we have derived the formula for the mean and the variance of a probability distribution and use this already in case of a given probability distribution. So I'm writing down the formula. The formula for the mean is summation x multiplied by p of x. How can we work this out? We can multiply each value of x by its associated probability. So 0 times 0.0016 gives you 0. 1 times 0.0256 gives you 0.0256. And 2 times 0.1536 gives you 0.3072. So 0.3072. Then 3 times 0.4096 gives you 1.2288. Then 4 times 0.4096 gives you 1.6384. So adding them all, values of this column will give you the mean value. So 1.6384 plus 1.2288 plus 0.3072 plus 0.0256 would give you the mean value as 3.2. So that's the answer to the mean value. So mu of random variable x is 3.2. So on the average, we get 3.2 as the mean value. And what does it imply? That on the average 3.2 patients will be cured. On the basis of this experiment, if the probability of success is zero point 0.8 and we have tested this medicine on 4 patients. So this would represent the mean number of patients that may be cured. Now considering the formula for variance, that's sigma of x squared, has the formula summation x squared times p of x minus summation x times p of x whole square. This part we have already worked out and this is an answer of 3.2. Now we will work out as the next step the product of squared values of x with associated probabilities. So 0 squared 0 times 0.0016, that's 0. 1 squared is 1 times 0.0256, that's 0.0256. So first two values will be same as the probabilities because 0 and 1 are the values of x, and raising these two values to square doesn't make difference on the values. Now 2 squared is 4. 4 times 0.1536 gives you 0.6144. So no 0.6144. Then we have 3 squared. 3 squared is 9. 9 times that probability 0.4096 would give us 3.6864. And then 4 squared is 16. 16 times 0.4096 gives us 6.5536. Now add them all. 3.6864 plus 0.6144 plus 0.0256 and then plus 6.5536 would give you 10.88 as the sum of this column. So what we do, we will substitute in place of summation x squared times v of x, its value as 10.88 minus the mean value, which is we have computed already as 3.2, and raise it to square. So 10.88 minus 3.2 squared would give you 0.64 as the variance, and in the next step we will definitely work out the standard deviation. And the standard deviation is just the square root of this answer 0.64. That's 0.8. So how do we interpret this answer? That average variability for the number of patients to be cured is 0.8. So on the average, the standard deviation is 0.8 patients. Now I can tell you the direct way to verify your answer for the mean and for the variance. The mean of a binomial distribution can be directly computed as mu equals np, and the variance of a binomial distribution can be directly computed as npq. Now what's the value of n? It is 8 in our case, multiplied by the probability of success is 0.8. So when 4 is multiplied by 0.8, it would give us 3.2. Exactly the same answer what we have got already on the basis of this entire probability distribution. when each value of x is multiplied by its associated probability. Similarly, if we make a substitution in the formula of variance, n as 4, p as zero point 0.8, and q as zero point 0.2. So 4 times zero point 0.8 times zero point 0.2 would again give you the answer as 0.64 for the variance. The square root of variance would give you standard deviation. Okay, so this is how we can directly work out the answer for mean and variance following these two formula. I am labeling it as 1 and labeling it as 2, the formula for mean and variance of a binomial distribution. So that's all for this session.